In this concept video, we're going to be discussing some useful area formulas. Now, the formula that you know for triangles might be this one. The area is equal to 1/2 of the base times the height. That's great to know if you know the base and the height. If you're given a triangle, though, that maybe looks something like this, let's call it triangle ABC. So then we'd have side C here, B, and then across A. You don't know what this altitude is. That's the height. That presents a little bit of a problem for us. However, if we can drop an altitude down, we can actually use trigonometry to help us find this altitude. Let's call the altitude x. If we want to know what x is, let's say that we know this angle A, and we're just looking at this right triangle. What we can do then is we can look at the opposite side from A and the hypotenuse, and that's the sine. So the sine of angle A is equal to opposite over hypotenuse. If we wanted to solve for x, we would have x being c times sine of A. In this equation, A equals 1/2 base times height. Let's call the base this entire length right here, which is B. Remember, we introduced this altitude. This little short one is not B. From A to C would be the whole side opposite of B. So we can keep that as B, as our base. Our height is this x. If we take the x out and substitute what x is equal to, c sine A, we have a useful area formula based on sine. The reason why this is nice to write is because we don't actually have to find this distance right here. If this weren't there and we were given a triangle that wasn't a right triangle and we didn't know the altitude, but we do know a side, another side, and its included angle, then we can easily find the area. And I should mention that this A here, this big A, is going to be area. That's different than angle A. Maybe that's a little confusing. So I'll put area here, and area there. Okay? So we could also say, and this works if we did this differently, that we could have 1/2 AB sine of, you guessed it, C. BCA, ABC, as long as all the letters are different, you're good to go. You could also have the area as being 1/2. Let's see, we used BC, AB, we didn't use AC, and then also we need a sine of the angle B. So here are some ones that you want to know. Again, if you have two sides and an included angle. Sometimes you have to do a little bit of legwork to find one of these using the law of sines or the law of cosines. Let's talk about a different area formula. And this area formula is nice to use for triangles where you're given all three sides. So this is Hero or Heron's formula. I'll write that over on the left-hand side for you. We'll do Hero's formula because I think it sounds better. Sometimes some people say this is Heron's formula. In Heron's formula, we use the semi-perimeter. So the area is equal to S times S minus A times S minus B times S minus C, where S is equal to 1/2 of A plus B plus C. And S is known as the semi-perimeter. I believe that's where the letter S comes from. So usually what you would do is you would find S first, then you would use that value of S here, and it appears in 4 spots, and then A, B, and C are just those 3 side lengths of a triangle. So this is a nice one to use as well.